The question says what are hybridization states of each carbon atom in the following compound. In the given compound we have to determine the hybridization of each carbon. Okay, and regarding hybridization we have learned by determining the number of sigma bond we can find out hybridization. Okay, for example, if the element is forming 2 sigma bond, let me write here, this is number of sigma bond, and we have hybridization is there. Okay, if the element is forming 2 sigma bond, then it will be sp hybridized. If it is forming 3 sigma bond, then it will be sp2 hybridized, and if it is forming 4 sigma bond, it will be sp3 hybridized. Okay, based on this information we can answer this question. Okay, now in each compound we can calculate the number of sigma bond formed by the carbon, and then we can apply this information. First we have CH2 double bond C double bond O is there. We can draw the structure. We have carbon to the first carbon 2 hydrogen are attached. Okay, then double bond C is there and double bond O is there. Okay, look at the environment of first carbon. You can see it is forming 3 sigma bond. How? The single bond is always sigma bond, and in double bond one is pi bond and another is what? Sigma bond. So now you can see this carbon is forming how many sigma bond? It is forming 3 sigma bond, and based on this information you can see it is sp2 hybridized. If 3 sigma bond are there, then it will be sp2 hybridized. Keep in mind we consider only sigma bond, we do not consider pi bond in determining hybridization. Okay, similarly we can calculate the number of sigma bond formed by this carbon. Now you can see pi bond, sigma bond, this side pi bond, and it is also sigma bond. So now you can see this carbon is forming how many sigma bond? 2 sigma bond, and based on this information you can see it is sp hybridized. Okay, first carbon sp2, second carbon sp. Now move on to the next compound. We have the next compound. Let me remove it. Next compound is CH3 CH double bond CH2 is there. So we can draw the structure. This carbon is there, and to this carbon you can see 3 hydrogen are attached. Okay, next we have C, and to this second carbon you can see 1 hydrogen is attached. Then it is forming double bond. Then we have CH2. I can mention H, and H is there. Okay, by drawing this structure, it will be easier to determine the number of sigma bond. Single bond is always sigma bond. You can see this is sigma bond, sigma bond, sigma bond, and this is also sigma bond. Okay, so now you can see this carbon, you can see 4 sigma bond are there forming 4 sigma bond, and based on this you can see it will be sp3 hybridized determined. Okay, now go for the second carbon. You can see it is sigma bond, it is sigma bond. We have double bond. In double bond one bond is pi bond and another bond is sigma bond. Okay, so now you can see this carbon, second carbon is forming how many sigma bond? First sigma bond, second sigma bond, and third sigma bond. Means it is forming 3 sigma bond, and hence it will be sp2 hybridized. Okay, now move on to the third carbon. You can see single bond always sigma bond. Okay, second one is also carbon hydrogen sigma bond. You can see first sigma bond, second sigma bond, third sigma bond. It is also forming 3 sigma bond, hence it is also sp2 hybridized. Okay, forming 3 sigma bond, it is sp2 hybridized. Sorry, now we move on to the next compound. So we have the next compound CH3 whole twice and CO. This is ketone actually. Okay, so we can write it C, and to this carbon 3 hydrogen are attached. I can write this compound in this form also, like CH3, and it is C double O, and it is CH3 is there. Like this we can write. Okay, so here we have C double bond O, and here we have next third carbon is there attached 3 hydrogen. Now find out the number of sigma bond. You can see single bond always sigma bond, and this is also sigma bond. Hence you can see this carbon is forming 4 sigma bond, and then based on this information it is sp3 hybridized. Move on to the next carbon. You can see sigma bond. This is sigma bond. In double bond one is pi bond, another is sigma bond. So 1, 2, 3, it is forming 3 sigma bond. Hence we can say it is sp2 hybridized. Now next carbon is there. You can see this carbon, first carbon as well as the third carbon, your last carbon we can say are in the same environment, and same environment in the sense equal number of bonds and same type of bonds they are forming. This is sigma bond, sigma bond, sigma bond, and it is sigma bond. Hence we can see it is forming 4 sigma bond, and then it will be also sp3 hybridized. Same environment, same number of sigma bond, and same hybridization. Okay, now move on to the next compound. We have CH2 double bond, we have CH2 double bond CH, and CN is there, cyanide group is there. So we have CH2. So C to this carbon you can see 2 hydrogen are attached. Then we have double bond, and then to this carbon 1 hydrogen is attached, and then we have CN and C triple bond, it is N is there. Okay, this is the compound we have. This CN means C triple bond, N is there. Okay, find out the number of sigma bond. Single bond, sigma bond, single bond, sigma bond, double bond, 1 sigma, 1 pi bond is there. So you can see this carbon is forming 3 sigma bond. Then it will be sp2 hybridized is there. Okay, now move on to the next carbon. You can see single bond, sigma bond, this is also sigma bond. Hence you can see it is also forming 3 sigma bond, and it will also be sp2 hybridized. Move on to the next carbon. We have next carbon. You can see it is sigma bond, but in triple bond 2 pi bond are there and 1 is sigma bond is there. So this is pi bond, this is pi bond, and middle one is sigma bond. So now you can see the third carbon is forming how many sigma bond? 2 sigma bond. Then I write this is what? Sorry, it is 2 sigma bond. Since it is forming 2 sigma bond, it will be sp hybridized. Okay. Now last we have C6H6, that is benzene. Okay, so the students who have learned about Huckel's rule, they might be knowing about the hybridization, because in Huckel's rule by finding the hybridization we find out the shape. Okay, we have benzene ring. We can draw the structure. It will be easier to find out the number of sigma bond. So benzene ring case, this is the structure we have. This is the structure. Okay, this is the structure we have. It can also be written, we have CH2 double bond CH, single bond CH, then double bond CH is there, then we have single bond CH, and then double bond, and it is CH, and this is what we have structure. It can also be written like this. Okay, you can see in this benzene ring, each carbon is in the same environment in the sense they have equal number of sigma bond and pi bond. Hence each carbon will have same hybridization. Any random carbon we can pick, let's say I'm picking this carbon. Okay, so you can see here we have hydrogen. To each carbon 1 hydrogen is attached. To each carbon 1 hydrogen is attached. You can see 1 hydrogen. Single bond, always sigma bond. This is sigma bond, this is sigma bond, this is sigma bond, and this is pi bond is there. So you can see this carbon is forming how many sigma bond? 3 sigma bond is there. Hence we can say it is sp2 hybridized. Each carbon in this benzene ring is in the same environment, having same number of sigma bond, and hence each carbon will be sp2 hybridized. If you like this video, please share and subscribe to the channel.